It's not my intention to startle anyone, but I've got a bit of a tool storage issue, in particular with my plier rack, which is suffering from overpopulation. A petty problem, I realize, but every time I reach for one of these, I'm like... So I thought to myself, hey, why not use this as an opportunity to make a mountain out of a molehill? To make a CNC Basics follow-up. As you can see, my system is pretty basic. Just whatever wood I happen to have on hand, filled full of holes. And left to my own devices, I'd probably do just that. Maybe move to a slightly smaller bit, and perhaps stagger them to get more tools in the limited wall space that I have left. But as I mentioned, this might be just a simple enough part to use in a basic CNC walkthrough. A step-by-step without complications of elaborate setups or toolpaths. Something we might instinctively already know how to make with nothing more than a 2x4 and a drill bit. Now this is just a piece of pine a little bit longer than the old tool rack. It should just fit in that space that I have for it. I felled this, rough sawn it, kiln dried it, and then planed it to size. Wait, I'm sorry, I misspoke. I meant to say I went out and I bought it. And what I'd like to do with it is pretty basic. I'd like to keep the nut driver holes and locations the same, because those are the nut drivers that I have, and make the plier locations ovals. And given what oval Forstner bits cost, this is a great job for the CNC router. To spice things up a bit, I think I'm going to come in and engrave the nut driver dimensions on the front face of this rack. A tad superfluous maybe, but it'll give us an excuse to get into a second setup 90 degrees away from our initial setup. The other thing it'll let me do is mark off the mounting hole locations so I don't have to drill new holes in my wall to mount the new rack. Now, to make up for the fact that this isn't the most exciting part to be machining on our CNC router, just for this video, I went out and I bought you guys a kitten. Now, just to set the stage, as I mentioned in part 1 of the CNC Basics, we're going to be using a CNC machine. The CNC machine is not a CNC machinist. It's still up to us, the operator, to tell it what to do step by step. Basically, all the steps we'd go through in making it manually, thought through ahead of time, and turned into instructions that the machine can follow. We're going to need the G-code to make this plier rack. And to get that, in this case, we're going to jump into Fusion 360. So behind every good relationship with a CNC machine, there's a solid CAD model. I've gone ahead and done the CAD already. Otherwise, I'd likely be standing around all day waiting on you bums. Anyway, I've built two models, the old rack and the new. We don't really need the old one for the cam, but I want it in there as a reference, both to pick up the mounting holes and because I know the changes I wanted to make based off of the original and not necessarily like fixed objective dimensions. I've got the holes in the rack for the nut drivers, a couple of more just for kicks, and then my oval slots for all the pliers. On the front face, I've got the dimensions engraved, and there's 3 holes picked up exactly from the original plier rack. Again, so I don't have to drill new anchors in my wall. I'm already in the cam module. The actual CAD would have been done here in the model space. You can see you just click through between the two. But let's jump back into the cam space. We get our cam toolbar up along the top. Now the workflow here is more or less as it would be standing in front of a milling machine. The first thing we'll want to do is create a new setup. We get the setup palette pop up on the screen, and as is common in Fusion, the way to work with these pop-up palettes, well in my case they pop up, it depends how you have them set up. You'll want to work through the tabs sequentially, starting from the top and going down to the bottom. You may not need all the tabs or all the options, but that's sort of the general workflow. Start at the first tab, work your way down, go to the second tab, work your way down, go to the third tab, work your way down. And that should give Fusion all the information it needs to make the part that you're trying to get out of it. So just working down here a step at a time. The operation is a milling operation, that's fine. In the WCS, the work coordinate system, we'll just want to set up how the part is oriented on our machine. So you can see here the default has the Z-axis pointing sort of towards me, towards the operator. We want that to point up with the X direction pointing to the right. We basically want to match how our physical CNC machine is set up. So in orientation, you have quite a few options to do this. I'm going to select Z-axis plane and an X-axis direction. So when I click on that, it'll ask me for the Z-axis plane, and I can pick the top of my workpiece. You see the Z-axis has now popped up vertically, and the X-axis looks like it's in the correct direction. So I don't really need to do anything in the X-axis selection. You could flip that, for example, if your machine is set up a different way. Usually the X-axis is positive off to the right. Before I pick the origin here, I'm going to go down into this model area. It's currently got 2 bodies. Again, we don't need the old rack, so I'm just going to X that out and pick just the body that I'm interested in the CAD. That will ignore all the other CAD sort of in the CAD space, and the cam will be based off just this model selection here. Now I can go back and pick the origin that I'd like to use, select point, and come back to the left top corner of what will become my new plier rack. That does it for the first tab in the setup palette. Next I'll go over to stock, and by default you can see it's adding a little bit of material all around my CAD. In this case it looks like it's adding 1 millimeter. You can see it's sort of breathed out those dimensions. And that would be more or less normal for a milling operation because these might be rough sawn blocks and you want to face them to final dimension. In this case, since I'm using a store-bought piece of lumber and I don't really care about the external size, I'm not going to add any additional stock. In the post-process tab, you can add some information. We'll have a chance to do this when we export the G-code, so I don't usually worry about this tab. I hit OK. Just for clarity's sake, I'm going to go up and hide the old rack, just turning off that light bulb there. So we've got our first setup 1. And again, it's just like you're standing at a machine. We've basically set the work up on the milling machine table or in the lathe chuck. The work is ready to go in the orientation that we'd like to machine it. The next step may be to load the tool that you're going to use, the end mill of the right size, the proper stick out, etc. So let's go up to the Toolpaths menus. After setup, you get 2D, 3D, drilling, etc. You can have fun exploring those yourselves. But since this is a simple, basically pocketing operation, I'm just going to go in and use a 2D. I guess we could try adaptive clearing. A lot of these toolpaths or toolpath strategies will get you to the same end result. Like we'd still end up with the same pockets and holes. It's just different toolpaths may be better suited to the type of geometry you're trying to do. And there's little pop-up descriptions that are pretty handy. You can fool around with them, but most of them are pretty straightforward. Slot, 2D contour, face. They put some thought into naming their toolpaths. Let's try 2D adaptive. Again, we get another palette pop-up, and the first thing it asks us for is to select a tool. It'll obviously need that tool information to be able to generate the toolpaths, decide how fast it can move it, where the tool might fit, etc. I hit select, and I've already got these set up in my local library. I'm going to be using an 8mm flat, basically a router bit. And just like the other menus, we'll want to work our way top to bottom, left to right through the tabs. I don't want any coolant. All of this other feed and speed information has been pulled in from the tool library. I just give it the once over. Everything seems to look okay. Once we're happy with that tab, we'll click over to the next one, and here it's asking us for the geometry that we actually want to machine. I'm going to go through and just sort of pick the bottom of all the holes that I'd like that toolpath to clear out. None of these other options are really relevant to what I'm trying to do, so I'll move on to the next tab, which is the Heights tab. The Heights tab shows you sort of visually the planes where the tool will reach during the machining process. I'm not sure why I would expected this blue plane to appear at the bottom of my work, but I'm just going to go down to bottom height here and change that to stock bottom. To make sure the tool gets all the way through, I'm just going to give it a bit of a negative offset, maybe -1. That now will tell the tool to drop a little bit lower than the bottom of the stock just to make sure I make it all the way through. The other planes are more or less clearly labeled: retract height, top height, clearance height. That's where the tool is going to be flying around as it moves from one feature to the next. So this looks good. Let's move over to the last two. Now the last two, passes and linking, refer respectively to essentially where the tool is. So while the tool is in the work cutting a feature, that's all of the passes tab. When the tool is not engaging the work, it's not cutting the features, it's sort of helixing in or flying out or flying to the next pocket. That's all in the linking tab. So let's do this one at a time. In the passes tab, I don't want to leave any stock. I know I'm sort of jumping down the list there. You'd leave some stock if you wanted to come back for a finish pass. I'm going to leave all these top options at their default. Climb milling is fine. I do want to turn on multiple depths. I'm not going to try to route a 1-inch thick piece of wood all in one pass. I'll leave that at 10 millimeters and see how that looks. So it should do it in 10, 25, 2.5 depth cuts. I usually leave unless I want to do something very specific, I usually leave the linking at its defaults. It's going to helix into the cut with these parameters, the helix diameter and pitch and ramp angle, all that kind of stuff. I usually come back and fix this if there's a problem when it generates the toolpath. At this point, I'll hit OK and let it sort of crunch through it. If you look up on the left here, there are some percentages as it's making its way through the toolpath, and we'll wait for it to give us the preview of what it thinks we've asked it to do. All right, so right off the bat, you can see we have a problem. That toolpath is only going to clear out the first 4 larger slots on the far end of the plier rack. That's obviously not what we wanted to do, so we'll go here and edit. And from experience, I can tell you that's being caused by the diameter of my helix. So the tool won't fit into these smaller pockets because I've told it to kind of come in with a large ramp diameter with an 8mm bit, and the pocket's not big enough to accommodate that. So I'm just going to drop this diameter down to maybe half that. This is soft pine, so it's not really a big deal. I'll hit OK, and it'll go back and recalculate that toolpath. So that looks a lot better, at least from here anyway. It's hit all the features we intended it to. Now I'm just going to change the display, I guess wireframe, and we'll take a look at what it's doing. So it's ramping down, sort of helixing, down to that 10mm depth, cleaning that pocket out, coming down another 10, cleaning it out, coming down the last 5 or 6 to get to the bottom here, and finishing that particular pocket. It'll then pop out, move to the next one, all the way down the line. Now, although that be more than sufficient for my plier rack, I'm just going to trick it out a bit with a bit of a chamfer. I just want to knock off, quote-unquote, the sharp edges of all those pockets. Just like before, we get the toolpath menu, and it asks us to select a tool. I've already got one defined. I've got a 1/2 inch, I'm working in metric, but it's essentially a 1/2 inch V-bit for my router. I hit OK. The speeds look more or less all right. Click over to the geometry tab and just pick the edges that I'd like to break. I don't really need to worry about the heights tab in this case. I'm going to jump over to the passes tab and into the chamfer dimensions. Let's say we give it a 2mm chamfer. The chamfer tip offset, I think if you hover over it, there's the graphic. It's the amount you want the chamfer tool to kind of come down into the feature before it starts to cut the chamfer. Like how high up the side of the chamfer tool you want to set the machine to cut. It's a V-bit. You wouldn't want to leave this at 1 because you'd be working at the very tippy tip of the tool. I'll just drop that down, 3 millimeters maybe. Hit OK. Let it generate, and we'll take a look at what that looks like. So there we see the preview of the V-bit. It's coming down to about this position, working its way around, and it should knock a 2mm chamfer on these edges. If you like to see that, you can right-click and have it simulate the toolpaths. Here you can hit play at the bottom and sort of scrub through what it's doing and change the speed. But I like to just click ahead, kind of go to the next track directly, see the end results. Show the stock. We'll zoom in here, turn the quality up to high. I'm just trying to get an idea of what that chamfer looks like. That looks aggressive. I think I'm going to go back in the toolpath and drop the size of that chamfer a bit. In the chamfer settings, maybe it's this clearance. I'm going to drop that down to 0. The clearance is just to make sure you don't run into other features that may be sticking up. Say you have bosses coming up out of the top surface. Since this is just a flat piece of wood, I don't need to worry about that chamfer clearance. Nonetheless, I'm going to drop that chamfer down to 1.5. Hit OK, and we'll simulate just that chamfer now. I'll skip ahead. And so there's what the chamfer operation will look like if we hadn't have taken the pocket out beforehand. It looks good to me. At this point, I like to check the machining time. So if I right-click my setup, select the machining time, it gives me an estimate of how long I'll have to wait for it to make this part. In this case, almost 31 minutes. That seems a little excessive to me. It's soft wood. I can probably override that feed rate in the mock software and get that time down. I hit close, and that does it for our first setup. Next up is the front face here, in particular the size engravings and the 3 holes for mounting the thing to the wall. Again, just like you do in real life, you have to make a new setup. In our case, we'll have to rotate the work 90 degrees, so the face we want to work on is pointing up. New setup, and it's the same story as before. For clarity's sake, I'll jump to stock, remove the stock offset, go back to setup, and now pick the same z-axis and go through the same steps. Pick my z-axis plane and my x-axis direction. Again, it's kind of got it right. I just want to move the origin to the top left corner. In setup 2, I'm going to maybe cheat a little bit. I'm just going to use one tool, engrave the numbers, and just kind of spot where the mounting holes go instead of switching through to a drilling operation. With the riser block, I'm not sure if I have the clearance on this machine to actually load the length of drill to get through this part, but it's easy enough to just hit that with a hand drill. So in 2D, I'll pick an engraving operation. It's already got my last tool in there. That was the V-bit that I used to chamfer on the first setup. So I really just need to go in and select the geometry. Now these are just extruded cuts. They go pretty deep, but the engrave tool is only going to cut as deep as the width of the cut will allow a V-bit to go, right? It'll come down, and when both sides of the V-bit hit kind of the bounding blue lines, that sets the depth. Being sure to pick up all the little islands inside of the numbers. As I mentioned, I'll pick the mounting hole locations too, and it'll act as a bit of a spot drill. Hit OK. It should calculate that pretty fast. Well, that didn't go as planned. I mean, it looks like it's doing the engraving well. You see it comes in and even kind of sharpens those corners, but it skipped my mounting holes. So I'll go in and I'll do a drilling operation, again with that same V-bit. Go over into the toolpaths and pick the holes that I wanted to drill. The only thing to be careful here is it's now running that V-bit all the way down the hole. Since I only really wanted to spot face the surface, I'm going to go into the heights tab and change the bottom height from hole bottom to hole top and just drop it, I don't know, 40 or 60 thou. Should have been a negative. And now we see the yellow line extends about 60 thou down below that surface. And that pretty much does it for the plier rack. I'm going to export these as two separate programs. But if you had, for example, like a fourth axis, like an A-axis that could rotate your work, you could set it up that, setup 2 would rotate 90 degrees, present this face up to the router, and continue along your merry way. I'm just going to right-click each setup and post-process. My post-processors are already set up for a Mach 3 mil. I've got a file path. I'll call this rack top and hit post. I'll do the same thing for setup 2, post-process, call it rack front, and hit post. That's it. We have our two programs, G-code for the top and G-code for the front. Let's get things set up on the router table. I haven't touched this riser since I did the pig cutting board in the last video, so I still have the two dowel locations from before. If I put in a couple of dowels and press my work up against those, I should be close enough to square for this plier rack. Now in my case, I've drilled a couple of holes in each end because I can, but if you couldn't, you obviously would need some other way to fix this to your table. Either clamps, maybe double-sided tape, a vise or 3, anything to keep it from moving while you're trying to cut it. Next, I want to reference the machine. Referencing is essentially the way the machine knows how big it is and where the cutting head lives in that available envelope. When I hit the Reference All Axes button, each axis will move in turn until it hits its limit switch. The machine is now at its machine origin, which will be different than our work origin. Since last we met, I've been making a few small upgrades to my machine, the biggest one of which is a touch screen. I can't convey how much fun it is. It's like a totally different machine to work at. Second, I'm trying Mach 4. Anyway, we just homed the machine. You can see it's at some weird coordinate based on where it started. And if I hit the machine coordinates button, in my case, I'm 3 millimeters off of each axis. So I hit the limit switch and it backs off 3 millimeters. And I can toggle between machine coordinates and sort of absolute and relative coordinates. I'll come out of machine coordinates. I'm going to jog the table to my work origin and zero these axes out. Once I'm close, I can sort of sneak up on the origin location that I want for this job. If this were something critical, you'd use an edge finder, of course. And once I'm happy with that, I can just come in and zero my DROs. I should be able to load my G-code and see it in the preview window. At this point, I'd just hit cycle start and let it do its thing. So in a completely unexpected turn of events, something started to go wrong. Turns out that this piece of lumber has quite a bit of a bow in it. So as my features started to come across, they have gotten dangerously close to the edge. This would have only gotten worse, so I stopped it. So I've got my only other piece loaded in here. I'm going to run this again. I did make a couple of changes. I found from this run that I can go much more aggressive on depth of cut. I was doing 10 millimeters, now I'm doing this full depth, 1 inch in 2 steps. I also changed these nut driver holes to circular pockets instead of, I think it was 2D adaptive. That got my cycle time down from 30 or 31 minutes on this original part to something like 8 or 9 minutes on this new part. Live and learn. Now, in order to proceed to the next operation, the 2D chamfer, the G code has a tool change command in it. That was also all done in Fusion in the setup. I don't have an automatic tool changer. So the machine has stopped. I've had to manually change the tool, and now when I hit cycle start again, it'll pick up. Before I can do that, I have to zero the new tool out. So X and Y, it can still keep track of, but it doesn't really know what the new tool stick out is. Like, for example, I could have installed it 1/8 of an inch higher or lower than the previous tool. So I touch off. Here it's not that critical. And I zero the Z DRO. Again, just like you'd be standing at a manual mill. Zero your DRO or zero out your hand wheel. If this were more critical, I'd probably use like a shim, a couple of thou, and then just take that off of the Z height. Now I can hit cycle start, and it should fly through there and add all the chamfers. Before I get into the second setup, just a quick note about that chamfer. I don't know if you noticed, but it turned out a little bit wimpy. So what I did was come back in, drop the tool, another 40-50 thou, and reran just that part of the G code. That just cut a little bit of a nicer chamfer on there. And you can do that by scrolling to the line in the G code you want to start from and hitting the Run From Here button. And the next step is to engrave and spot the front. In order to do that, I'm going to have to set the work up at 90 degrees. And I've just screwed it to the old messed up rack, and I'll screw this down to the table. Now I just go through the same steps as before, setting the work origin that I like, left back corner in my case, and I zero out the DROs, and I can run program number 2. All right, so all in all, I think that turned out pretty all right. I feel a lot better about that plier rack. My daughter found this cat in the bushes, I don't know, a couple of weeks ago. She was waiting for the school bus and I guess heard this thing crying. He was in pretty bad shape, hanging out on death's doorstep. That's what our neighbors call our house. So now I've got a shop cat. I don't know yet if I'm a shop cat fan. I have visions of turning on the lathe and just seeing a big puff of orange hair fly out from behind it. At any rate, as I mentioned, I'm happy with how that turned out. I know nothing groundbreaking, but now I've got a new plier rack and they don't put up a fight coming in and out of there. I appreciate you sticking through that, and thanks for watching.